Hello friends, welcome to this channel Break the Code, and in this video I will be teaching about how to implement multi-threading in Java. So in this video I will be using Notepad and CMD, so get ready with both. Hello friends, now let's get started to this main thread. So what is happening in this program is that the reference to this current thread is obtained by using current thread method, and this reference is stored in the variable t. Now the details of this thread can be obtained by this following code. Now to change the name of the thread, you can use setName method, in which you can type the name of this thread. After typing this, you can see the details about this thread, and you will find that the name has been changed. Now in this for loop, what is happening is that it is countdowning from 5 and it is taking a pause of 1 second to display the output. Now the sleep method, what is happening in this is that the argument is actually the delay period in milliseconds. So that's why it is taking the pause of 1 second. Now it is kept in this try catch method because if any other thread try to interrupt this thread, this will throw an interrupted exception exception. So here what the message will be outputted. So to check the validity of this code, now go to this CMD, type javac. As you can see, this program successfully compiles. Now to get this output, Java. So you can see this pause is after 1 second pause, this is displaying the output. Now let's move forward to see how to create thread. Thread can be created by two ways. Either we can implement the runnable interface or we can use the extending the thread. So in this, as you can see, we are using in the how to implement the runnable interface. So in this we have created a new thread constructor. So in this, as you can see, this statement, this is being passed as a first argument. So what will does that we want new thread to run a method in this object. So after this, the start has been called, which will start the beginning of the for loop, which is in the run method. After this start has been executed, this new thread constructor will return to the main method, and in this the main thread will be start executing. After this, main and child thread will start executing simultaneously until the loop finishes. So to check the validity of this program, first let's compile this in CMD. As you can see, our program successfully compiles. Now to check this output, as you can see, first the child thread starts beginning. After this, the execution of main thread takes place, and thus this completes. When loops completes, this program exits. Now let's see to implement the extend thread. So this program generates the same output as the previous one. As you can see, the child thread is created by instantiating an object of new thread, which is derived from thread. Now notice that the super inside new thread, it invokes the following form of constructors. So let's see the validity of this program. First let's compile it. As you can see, it successfully compiles. Now you can see it is generating the same output as that was of previous one. So far we have been using only two threads, the main thread and one child thread. However, our program can spawn as many threads as it needs. So the following examples depict the same. So to check the validity of this program, simply open CMD and compile your code. As you can see, this program successfully compiles. Now to check this output, now as you can see, once the thread once started, all the three child class share the CPU. Notice the call to sleep 10,000 in the main. So this causes the main thread to sleep for 10 seconds and ensures that it will finish last, as you can see in this following program. There are two ways exist to determine whether a thread has finished. First, you can call isalive on the thread. This method is defined by thread, and its general form is shown in the following example. The isalive method returns the true if the thread upon which it is called is still running. It returns false otherwise. While isalive is occasionally useful, the method that you will more commonly use to wait for a thread to finish is called join. This method waits until the thread on which it is called terminates. Its name comes from the concept of calling thread waiting until the specified thread joins it. The additional form of join allows you to specify maximum amount of time that you will want to wait for the specified thread to terminate. So here is the improved version of the preceding example that uses joins to ensure that the main thread is the last to stop. So to check the validity of this following program, simply open CMD and type and compile your code. As you can see, this code successfully compiles. Now to check this output, and hence you can see here, this is the due to this alive method, and at the end you can see this main thread is last one that exits. Now let's move forward to see how to set the priorities in the thread. So the following program demonstrates the same. So what is happening in this program is that we have created two threads, high and low, and we have set the priority of high 2 level above the normal priority and low 2 level below the normal priority. Here the normal priority's value is 5 as it is standardized value in Java. So what is happening in this program is that each thread is given the 10 seconds to execute and run through this loop, and it counts the number of iterations when it goes through this loop, and the result is displayed in this code, in other this following code, sorry. Now one more thing about this code is that here running is preceded by the keyword volatile. It is used to ensure that the value of running is examined each time the following loop iterates. So without the use of volatile, Java is free to optimize the loop in such a way that the local copy of running is created. The use of volatile prevents the optimization, telling Java that the running may change in the way not directly apparent to the immediate code. Now to check the validity of this following code, just open CMD and compile your code. As you can see, our program successfully compiles. Now to check this output, since each thread has been assigned the time for 10 seconds, so total it will take 20 seconds to display the output. So after 20 seconds, you will get this following output. Here it demonstrates the time allocated by each thread by the CPU. Now let's see about synchronization. So to understand the synchronization, first we need to understand the need of synchronization. So this program demonstrates the same. So what is happening in this program is that first one, the call me has a single method named call. The call method takes a string parameter called MSG. This method tries to print MSG string inside of square brackets. The interesting thing to notice is that after call prints the opening bracket and the MSG string, it calls thread.sleep, which pauses the current thread for 1 second. Now the constructor of the next class caller takes a reference to an instance of the callMe class and a string, which are stored in target and MSG respectively. The constructor also creates run method of caller calls the call method on the target instance of callMe, passing in the message string. Finally, the sync class starts by creating a single instance of callMe and the 3 instances of caller with each with unique message string. The same instance of callMe is passed to each caller. So to check the validity of this program, first open CMD and simply compile this program. Here you can see this program successfully compiles and prints the output. But one more thing you need to see that, as you see, by calling the sleep, the call methods allow execution to switch from to one thread to another. This results in the mix-up of the output of the 3 message. For example, if I again compile this code and again try to get the output, it will be different from the previous one. So what is happening in this is that the race condition is being built up. So what is that Right? There's nothing to stop all the three threads from calling the same method on the same object at the same time, because the three threads are racing each other to complete the method. So this example uses sleep to make the effect repeatable and obvious. So in order to avoid this, we use the synchronize method. Now to get the synchronized result, so what we will do is that we will just synchronize the instance of this run method. So we have synchronized the target of the target instance of this run method. So to check the validity of this program, simply open cmd and type java c java. As you can see, this program successfully compiles. Now to check this output, as you can see this, now the output which we are getting is now in a synchronized way. And this, but in this code also, we have got the same output as the preceding example, because each thread waits for the prior one to finish this before proceeding. Now let's see how the thread communicate with each other. So they communicate through by using the various methods. Some of are the wait, notify, and notify all. This following example demonstrates the use of wait and notify method. So to begin with interthread communication, we consider small sample program that incorrectly implements the sample form of producer-consumer problem. It consists of four classes: queue, that is the queue that you are trying to synchronize; producer, the threaded object that is producing queue entry; consumer, the threaded object that is consuming the queue entry; and the PC, which is a tiny class that creates the single queue, producer, and consumer. So when you will go through this following program, and when you will come to this output of this following program, so to check this validity of this following program, first go to this directory where my Java environment has been saved. As you can see, this my program compiled successfully. Now to check this output, although the put and get methods are on queue are synchronized, and due to which nothing stops the producer from overrunning the consumer, nor will anything stops the consumer from consuming the same queue value twice. Thus you get the erroneous output as shown here. Now let's see the improvised version of this producer-consumer relationship in this Java coding. So here we have used the wait and notify method to demonstrate. So inside get, wait is called, as you can see. Now this causes its execution to suspend until the producer notify you that some data is ready. So when this happens, the execution inside get resumes. Now after the data has been obtained, the get causes the notifies. Now this tells the producer that it is okay to put more data in queue. Now inside put, wait suspend the execution until the consumer has removed the item from the queue. And when the execution resumes, the next time of data is put in the queue and notify is called. This tells the consumer that it should now remove it. So to check the validity of this following program, simply open command prompt and type java c As you can see, this program successfully compiles. Now to check the output, now as you can see here, we have get the output, and this shows that our program is correct, and hence our this inter-threaded communications completes. Now let's move forward and see about deadlock. It is a special type of error which occurs when two threads have the circular dependency on a pair of synchronized objects. It is difficult to debug as it occurs rarely when two thread is time sliced in just the right way, and it may involve more than two thread in two synchronized objects. So to understand the deadlock fully, it is useful to see in action. So in this example, we create two classes A and B with methods foo and bar respectively, which pause briefly before trying to call a method in other class. The main class named deadlock creates A and B as an instance and then starts a second thread to set up the deadlock conditions. The foo and bar methods use sleep as a way to force the deadlock conditions to occur, as you can see in this following program. Now to check the validity of this program, so let's see. First, let's compile by using cmd. As you can see, this program successfully compiles, but let's see what happens when it produces an output. Now, because the program has deadlocked, you need to press Ctrl C to end the program. You can see full thread and monitor cache come by pressing Ctrl break on a PC. Now you will see that the racing threads owns a monitor on B while waiting for the monitor on A. At the same time, the main threads own A and is waiting to get B. This program will never complete, and hence here the deadlock conditions occur. Now let's see the suspending, resuming and stopping of threads. The suspend method of the thread class was deprecated by Java 2 because it can cause some serious system failures. As if we can use the important data structure and if we use the suspend method, this can cause the deadlock conditions due to which it can cause the system failure. And the resume method is also deprecated as it cannot be used without the suspend method. Stop was also deprecated because it too caused same as the suspend problem. Now the run method periodically checks to determine whether the thread should suspend, resume or stop its own execution. It is done by establishing flag variable that indicate the execution state of thread. If it is set to running, then the run method must continue the thread to execute. If it is set to suspend, then the thread must pause. If it is set to stop, then thread must terminate. Now what is happening in this following program is that we have shown how wait and notify method that are inherited from object can be used to control the execution of a thread. Now in this program, the new thread class contains the boolean instance variable named suspend flag, which is used to control the execution of a thread. It is initialized by initialized to false by the constructor. The run method contains the synchronized statement block that checks the suspend flag. If that variable is true, then wait method is invoked to suspend the execution of the thread. The mySuspend method suspends the flag to true, and myResume method suspends the flag modified to false and invoke the notify to wake up the thread. Now finally, the main method has been modified to invoke the mySuspend and myResume method, as you can see in this following code. So to check the validity of this following code, simply open command prompt and type As you can see, this program successfully compiles and it successfully generates the output which we were wishing to see. Thank you for watching this video. If you like this video, kindly like, subscribe and share our channel to learn more about Java.